What a beautiful day for science education. The sun is shining, the birds are chirping, the water is clear and fresh. Oh, hey there, little Timmy. You're just in time for the science lecture.
Lectures are boring and science is stupid.
I'm sorry, what did you just say to me, you little
Hey, you can't talk to kids like that. That's where you were fired from your university job.
No, I was fired for malpractice and secretly shuffling research funds to develop bioweapons. Anyway, that's beside the point.
Whatever. This water looks nice, and I'm going for a swim.
You know what? You're right. Let's take a break and you can go for a swim.
Yay!
So, how's the water, little Timmy?
It's great!
Great. That's great. Oh, little Timmy, watch out for the worms.
What worms?
Why, the tiny little microscopic worms that live in the water and are burrowing into your flesh as we speak. Then, they'll live inside you for years and years, causing horrific damage to your body in the process. Isn't the cycle of life beautiful? Ladies and gentlemen, welcome to Virus Wars, the show where I talk about bacteria.
Am I gonna die now?
Maybe. Where was I? Right, the show where I talk about bacteria and willful child endangerment. Except today. Today I'm covering a parasite, because parasites are fun. This adorable bugger is the blood fluke. Aren't you cute? Yes, you are. Yes, you are. The scientific name for these little critters is Schistosoma. Schist means split, and soma means body. And while that sounds like it would describe something cool and H.R. Geiger-esque, what it actually means is that blood flukes come in two types, male and female. That's weird, because blood flukes are flatworms, and most other flatworms are both male and female at the same time. But blood flukes have eschewed the hermaphroditic lifestyle, and instead they date, pair up, have kids, and even get divorced. Sometimes, all while chewing holes in your internal organs. But we'll get to that later. After all, we've got quite a bit to cover, and there's nothing better than a captive audience.
I can't feel my legs. Did the blood flukes eat my legs, mister?
Oh no, they don't do that. That's the neuroparalytic I injected you with. But let's get to the basics. The blood flukes, or Schistosoma, live all around the world. But like most of the nightmare horror creatures of planet Earth, they prefer hot tropical climates that don't freeze over in the winter. So Africa, South America, the southern parts of Asia, and the Middle East. There are a lot of different species of blood fluke, with one or two dominant per region, but they're all evolutionarily related, they all have a very similar life cycle. Not all of them infect people, but the ones that do typically result in a pretty similar pathology profile, with a few exceptions. But for now, I won't be singling any species out, just in case you're curious. Here's a list in Wikipedia order.
Schistosoma bomfordi, Schistosoma bovis, Schistosoma curasoni, Schistosoma data, Schistosoma edwardiense, Schistosoma guineensis, Schistosoma hematobium, Schistosoma harinasutai, Schistosoma hippopotami, Schistosoma incognitum, Schistosoma indicum, Schistosoma intercalatum, Schistosoma japonicum, Schistosoma kisumensis, Schistosoma leperi, Schistosoma malayensis, Schistosoma mansoni, Schistosoma margiboe, Schistosoma matei, Schistosoma menkongi, Schistosoma obuncatum, Schistosoma nasale, Schistosoma rodhani, Schistosoma sinensium, Schistosoma spindale, Schistosoma turkinistanicum.
Let's start with some basics. The blood fluke is a parasite, and a parasite is 1. Some sort of creature that needs another creature or host to complete some part of its life cycle. That's you in this case, Timmy. And 2. Causes some sort of harm to that host. By strict definition, all viruses are parasites, and a lot of bacteria that infect people and animals are also parasites. But lumping bacteria and viruses into the parasite category is unhelpful. So when biologists talk about parasites, they're usually talking about a eukaryotic organism. An animal, plant, fungus, or weird single-celled creature. Here's a fun fact. It takes a village to support a complex animal, and you actually have a ton of different creatures living in and on you, mostly of the bacterial kind. But these are actually helpful, and even necessary to your survival. Those are called symbiotes. A long time ago, a symbiote decided to cozy up to a cell and live inside it full-time, helping the cell with energy production. Eventually, it lost its ability to live independently and became a permanent part of the cells. Those cells were so evolutionarily competitive that they gave rise to pretty much all branches of complex life, from animals to plants to fungi. You have that symbiote inside your cells right now, and it's called a mitochondrion. It still carries some of its original DNA inside, separate from your cellular DNA, a relic of its evolutionary past. Pretty cool, right? That was a fun fact. But we're talking about parasites, and parasites hate you. And none hate you more than the blood fluke. Imagine an anger, roiling, and primal, tooth and claw coiled within a heart black as tar and vile as... Okay, it's just a worm. It's just a worm that has a weird life cycle, of which you're a helpful part. So, let's discuss it. Where to start? Okay. See that? That's a snail. And the snail is not a metaphor, it's the blood fluke's other host. See, Timmy, when you eventually poop or pee blood fluke eggs out into the water, those eggs hatch into little baby blood flukes called, let's use the English pronunciation here, Myricidia. But these Myricidia need some help developing, so they swim around until they find some snails. Then they worm their way into the snails. That's a metaphor. They're not worms yet. They're more like little swimmy balls. And then they begin to develop into sporocysts. Sporocysts make more sporocysts through asexual cell division and eventually leave the snail, developing into Cercariae, now looking like a slightly suggestive worm. At this point, they're just swimming around in the water looking for a compatible host, human or animal, depending on the particular species. And when they find one, they aggressively burrow through the skin until they reach your veins. Here, they lose their little tails, becoming schistosomuli, and are carried along to the liver, where they latch on and develop into male and female adults. Those adults move out of the liver back into your veins to find a new home. Most Schistosoma species prefer the veins feeding your lower intestine, except Schistosoma hematobium, which likes the veins feeding your bladder. All that's left is for the boys and girls to pair up and make lots of little eggs, which are then excreted either into the intestine or the bladder, and then back into the environment. As far as parasites go, this isn't the most straightforward life cycle, but also not the most complicated. It is, however, one of the most successful, with various species of blood fluke living all around the world, infecting both animals and people. In fact, it is one of the most common human parasites in the world after malaria, although its strict dependency on favorable environmental factors and specific snail hosts makes it almost unheard of in Europe or the continental United States. In the places where the blood flukes are present, the infection rate of the surrounding population can reach 100%. 100%. That's insane. So, what sorts of horrible things does the blood fluke do to you? Well, I'm glad you asked. First, it makes you super itchy.
Hey, I'm super itchy.
Yep, that's because the blood fluke Cercariae are currently digging through your skin, activating alarm signals in immune cells as they go along. That leads to a buildup of a protein called histamine, which, among other things, activates nerve cells responsible for making you feel that itching sensation.
So, is that all?
Oh no, Timmy, that's just the start. Next, once the blood flukes enter your body, your whole body's immune system will start to react, sending anti-parasite signals all over. This causes what's known as Katayama fever, and it's mechanically speaking, a full-body allergic reaction because the parts of your immune system that fight parasites are also the ones responsible for allergies, leading to a fascinating biological problem that...
Am I going to die?
Sorry, no. Probably not. Sadly.
What?
Nothing. No, you're just gonna feel tired, have a fever, a cough for some unknown reason, and also maybe some diarrhea and a rash. Maybe a bit of swelling in your liver or spleen, or some random combination of those for whatever reason. Kind of like the flu, or really any other disease that activates your immune response in a major way. It's pretty boring at the start, actually, but it gets good. Trust me.
I don't think I trust you very much.
You see, Katayama fever goes away on its own in a few weeks' time as your body gets used to the invaders, and as the worms themselves get coated by your body's detritus, so they're less alarming to your immune system in general. The real trouble starts when the worms lay eggs. See, the worms live in your blood vessels, like I said, and when they lay eggs, most of the eggs travel through the blood vessels into the surrounding tissue, into the intestine or the bladder, and then out of your body through your stool or urine. But some eggs don't make it that far. Some eggs get lodged in the surrounding tissue. Some get carried off in your blood to get stuck somewhere else. And that's a problem, because your immune system may have gotten used to the worms, but it really hates the eggs. So any place an egg gets stuck, you will get a local immune reaction, and the more eggs, the bigger the reaction. There are all kinds of local immune reactions, and I won't be covering the ins and outs even if you put a gun to my head. But the TLDR is that local immune reaction means local tissue destruction, and local tissue destruction means organ damage. What kind of organ damage? I'm glad you asked. The two most common blood fluke species live and lay eggs in the veins around your intestine, and that's the area they damage the most. This causes pain, bloody and mucousy stools, damage to the structure of the intestine like ulcers and polyps, as well as strictures and scars leading to a partial or complete blockage of the intestine. The bleeding causes anemia, and the damage to the intestine leads to impaired nutrient absorption, which in turn leads to nutritional deficiencies. Now, one species of blood fluke, Schistosoma hematobium, prefers to live and lay eggs near the bladder, which causes a different painful array of problems, starting with peeing blood and ending with a chronic inflammation and scarification of the urinary system, which leads to bladder damage, kidney failure, and bladder cancer. The urinary and genital system are interconnected, and eggs can lodge in the genitals of both men and women, the effects of which I won't describe in detail, but they are as unpleasant as you are probably imagining, and in the case of women can cause infertility and fetal defects during pregnancy. Alright, where else can the eggs go? Well, if they stay in the bloodstream, they can go to the liver, lungs, brain, or spinal cord. And it's actually hard to pick which of these is worse. If they go to the liver, they can cause damage to the circulatory system around it, restricting blood flow. This is called portal hypertension, and is a condition that is very hard to describe succinctly, but that essentially leads to impaired blood flow from places like the gastrointestinal tract, and this can cause some cascading and serious health problems. If the eggs get into the lungs, the situation could be even worse, because like with the liver, they also disrupt blood circulation through the lungs. This makes physical activity difficult and places massive stress on the heart, potentially cutting decades off your life. Eggs in the spinal cord can cause paralysis. Eggs in the brain can cause brain damage. So, to quickly summarize, intestinal blockage can kill you, kidney failure can kill you, bladder cancer can absolutely kill you, lung damage can lead to heart disease that will definitely kill you, and everything else can cause debilitating lifelong disease. Most of the long-term consequences of blood fluke infection have to do with the egg laying and the damage that the eggs cause. So, the severity of infection depends on 3 factors. 1. Your personal susceptibility to infection. 2. The parasite load, or how many blood flukes end up infecting and reproducing inside of you. And 3. How often you're exposed. The first is a matter of luck. The second depends on how long you're in contact with contaminated water and how contaminated that water is. The third depends on how frequently you're coming into contact with contaminated water. Like, are you a tourist who decided to take an inadvisable swim? Or do you live next to a contaminated river and do all of your laundry by hand using that river water? So that's all the fun stuff that blood flukes can do to you, but before we go further and describe how the disease is treated and efforts to control it, let's do some fun facts. Fun fact 1. The credit for the discovery of the blood fluke goes to Dr. Theodor Bilharz, a German physician and pathologist working in Cairo, who published his paper Dystomium hematobium and its relationship to certain pathological changes in human urinary organs in 1851. In fact, he had discovered both Schistosoma hematobium, which lives in veins around the bladder, and Schistosoma mansoni, which lives around the intestine. But he never realized that, and it took until 1902 for another physician, Patrick Manson, to figure that out. But we can actually go back in time a bit because, fun fact 2, the disease itself has been around forever and has been described thoroughly in Egyptian and Chinese medical texts going back thousands of years. A baffled Napoleon had to inquire from his army physicians why his troops stationed in Egypt started to develop urinary bleeding. Blood fluke eggs have since been found in Egyptian mummies dating back to around 1000 BC, and immune testing on even older human cadavers provides evidence of infection dating back to 3000 BC. The current medical archaeological record belongs to Piers Mitchell and his group, who found an egg in human remains around 6,000 years old. Fun fact 3. An adult blood fluke can live and lay eggs inside of its host for up to 2 years. 2 years. Fun fact 4. 2 years. So, treatment time. How do we treat this thing? Well, it's pretty complicated. You give someone a pill, and they're cured. Yeah, no, that's it. In the interest of fairness, it's actually 2 or 3 pills taken a few hours apart, all in one day, but it really is that simple. The drug is called praziquantel. It's an all-purpose anti-parasitic effective against a number of different infections. It probably works by messing with parasite calcium regulation, and it's pretty cheap. The important part of all of this is actually diagnosing and curing someone before they develop serious and irreversible organ damage, because that's a lot harder to treat. The broader problem is that once cured, the blood flukes can just infect you again, like nothing happened the next time you come into contact with contaminated water, which, in regions where the various Schistosoma species are endemic, is a lot of fresh water that is used to sustain most aspects of daily life. In communities living around endemic Schistosoma, infection and reinfection are not a matter of chance, they're a matter of time. So now, you need not just to treat the people, you need to treat the region. Possibly the entire country, which is not an easy task. However, Japan has managed to entirely rid itself of blood flukes, and Egypt has recently made good progress. The World Health Organization, champion of global health, crusader against infectious disease, fan of acronyms, and paragon of nearly comical levels of optimism, has set itself the goal of ridding the world of Schistosoma by 2025. Today. That's not happening, though in all fairness, their plans have been seriously derailed by COVID. But they, and the nations participating in their programs, have made genuinely optimistic levels of progress with a fairly straightforward strategy. Just treat everyone. The JTE strategy, actually called PC for preventative chemotherapy, but I like JTE more. The JTE strategy assumes that if blood fluke infection rate in an area is high enough, everyone in the area should get treated once or even twice a year as if they had been exposed and infected. And it works. Like, not just in terms of treating people who are infected with parasites, but in more of a big picture way. Humans are the most important host for blood flukes, and in the case of certain species, the only host. Interrupting the life cycle of people getting infected and shedding eggs into the water means less parasites in the water, which reduces infection rates, and this becomes a self-reinforcing virtuous cycle so long as the effort is maintained. The other big thing apart from JTE that the WHO recommends is WASH. That's not a setup for a joke. It stands for water, sanitation, and hygiene, and is more of a broad recommendation for infrastructural development and educational programs that reduce the spread of waterborne diseases, Schistosomiasis included. Killing snails, which are the intermediate host for the blood fluke, if you remember, has met with mixed success or outright failure in the past, since snails come back pretty quickly, and therefore gets the recommendation tier of, maybe if the specific situation calls for it. Nevertheless, we've seen that blood flukes can be eliminated from their endemic habitats with a combination of some effort, cheap drugs, and improved infrastructure. So, in an astonishingly rare move that surprises even myself, I'm going to express actual, real optimism that Schistosomiasis may be 95% eliminated by the middle of the century. 2025? Seriously? So for some diseases, I discussed their pandemic potential, or maybe bioweapon potential, and the resulting consequences here, but blood flukes can't really go global, or too far outside their current range, really. And they're a pretty terrible organism to develop a bioweapon out of, so hey, short section, yay! Okay, let's do our executive summary. Schistosoma. Pretty great. Infectiousness, 3 out of 10. Low rating relative to, say, the flu. A lot of things kind of have to line up for you to get infected by Schistosoma. Adaptation, 5 out of 8. Different Schistosoma species have spread all over the world, so from an evolutionary perspective, they have been quite successful. However, they're still pretty sensitive to environmental perturbations, and they don't evolve on the scale that bacteria and viruses do, so I'm giving them a 5. That is probably the highest rating I'll give anything multicellular and eukaryotic. Unmodified lethality, 3 out of 10. Unmodified lethality asks, just how deadly is this pathogen or disease without any medical intervention? I think people can fight me on this rating, but I think Schistosoma is incredibly harmful. It is one of the most harmful infections on the planet, but it is not particularly deadly. Gameplay. Seven out of 10. Intimidation factor, 7 out of 10. Blood flukes are quite intimidating. Apparently, Napoleon himself was unnerved when he took his army to Egypt and everyone started peeing blood. I mean, do you like peeing blood? Graphics. In this video, I have generally refrained from showing you anyone seriously afflicted by, especially chronic schistosomiasis. Those graphics are available on the internet if you are interested and are made of stern stuff. You have been warned, though. This is your warning. Renown, 3 out of 10. It's not that famous. Definitely not nearly famous enough for something that infects 200 million people a year. The WHO calls schistosomiasis an NTD, that's neglected tropical disease. But hey, maybe after some JTE and WASH, it will be DOA and WCAFAITC. Leave a comment to let me know what else you want rated. Out of 10. Overall score, 5 out of 10. I can't in good conscience give it anything higher than that, but I still like it though.
Can I go home now and see a real doctor?
Oh god, this bit. I forgot we're still doing this bit. I'm just gonna go before, the police, bye.
Hey, wait, no, I still can't feel my legs!
Remember, the horrors of biology are just a few clicks away.